All right, so we're going to run through a few examples here to show you how the slope formula works. The first example I'm going to work with is finding the slope between the 2 points 2 comma negative 3 and 4 comma 3. Okay, so again, the slope, the formula for slope, maybe I'll put that down here in the lower right corner just so you can reference it. M equals y2 minus y1 over x2 minus x1. Okay, so I'll keep it down there, we'll reference it. All right, so in this case, the slope then, if you think about this, the first one listed, I'm going to call it 0.1 and the second one 0.2. Really, it doesn't matter which one we choose. We could interchange them and we'll end up with the same slope. Okay, so I'm going to call this x1 and y1 and x2 and y2. Okay, so I'm going to correspond the numbers to the variables and then plug them in. So I want y2 minus y1. So I go 3 minus negative 3. Okay, so on top I have 3 for y1 minus, okay, I'm sorry, 3 for y2, and then the minus, and then y1 is going to be a negative 3. Okay, now I put the negative 3 in parentheses because I actually have a double negative here. I have the subtraction and then the negative from our value for y1. Okay. Now on the bottom, I'm going to have the difference in the x's, x2 minus x1. Okay, so it's going to be 4 minus 2. I didn't bother to use parentheses on those. I usually only use parentheses with the negatives. Technically, I really should put the parentheses in either way, but just quicker to leave them off. But when there's negatives involved, you really want to be careful there. So this double negative on top is really a plus, right? 3 minus negative 3 is the same as 3 plus 3. So that changes to 3 plus 3. On the bottom, 4 minus 2 is 2. Top will simplify. 6 over 2 is 3. Okay. So now with it simplified down to 3, that's of course a positive number. You could think of it as 3 over 1 to give you your slope, your rise to your run, your vertical change to your horizontal change. I just realized I haven't really talked about the rise to run idea yet. We talked about vertical change to horizontal change, but often people refer to that as the rise divided by the run. Okay, so how far you go up versus how far you go over. Okay, so just another alternate way of looking at slope. Okay, now with these 2 points, if you look at them on a graph, 2 comma negative 3 is over here in the 4th quadrant. 4 comma 3 is further to the right up in the 1st quadrant. And so the line going through them, oh boy, I'm way off on that one, is going to be a line going up and to the right. Of course, it looks better when I draw, right? All right, that one's not too bad. Okay, so it's rising up to the right. In fact, what you're going to find is that every time you have a positive value as your slope, the line will rise up to the right. It's the examples we saw in the previous videos as well. Okay, so we have a positive slope. Actually, I'm going to write that over to the side. Results in a rise to the right. Okay, so this will be rising up to the right. All right, let's look at another example here. Next example we'll do is negative 5 comma 4. and 3 comma 2. Alright, so again, the slope m is y2 minus y1 on top. So I'm not going to label all these, I'm not going to write it all out every time, but we got x1, y1, x2, y2, right? So y2 minus y1, it's the two y values subtracted. So I do 2 minus 4, and then on the bottom it's x2 minus x1, okay? So we get 3 minus x1 is negative 5. Again, with the negative number, I'm going to throw parentheses on there. And so when I simplify these, 2 minus 4 is negative 2. The double negative here is really a plus, so it's 3 plus 5. And of course, 3 plus 5 is 8, so negative 2 over 8, which reduces as a fraction to negative 1/4. Okay. Okay, now if I look at the graph again of these 2 points, I'm just going to sketch this out kind of quickly. Negative 5 comma 4 is going to be in the second quadrant, so you go back 5 and up 4, somewhere over there. And then 3 comma 2 is over in the first quadrant. You go over 3 up 2, and you can see that this line is not rising to the right like the last one. It's actually going down to the right, okay? Or you could say it's dropping to the right. Okay, and anytime you have a negative value for the slope, that means it's going to go down and over instead of up and over, okay? So a negative slope goes down to the right. Or sometimes I say it falls to the right. I'll write it that way. It falls to the right, okay? It's going down. Okay. Next example. Let's look at 2 points. We'll go with 1 comma 4 and 5 comma 4. In this example, again, looking at the slope, I want y2 minus y1. So we go with y2 is 4, y1 is also 4. And then x2 minus x1 is going to be 5 minus 1. When I simplify those, 4 minus 4 is 0, 5 minus 1 is 4. Now recall that in a fraction, or in division in general, anytime you divide 0 by any other number other than 0, you're going to get an answer of 0, okay? It's like if I had $0 and I divided them up to 4 of my friends, each of my friends gets $0. Maybe they're not my friends anymore. And so 0 is the answer there, okay? Okay, and what's interesting is when I plot the graph of these 2 points, 1 comma 4 and 5 comma 4, they're actually going to be situated on a horizontal line, okay, one going from left to right. And so that's actually always going to be the case. If the slope is 0, you always get a horizontal line. So I might need a little more space here. Let's go up here. Horizontal line, or oh, I wrote that wrong. That should say 0 slope. So let's say a 0 slope gives you a horizontal line, okay? That's how I want to write that. Okay, last example. last example, let's look at 2 comma negative 3 and 2 comma 8. So again, the slope, I'll look at my y2 minus y1 is going to be 8 minus negative 3. And the x2 minus x1 is going to be 2 minus 2. Okay, again, I'm going to simplify on top. 8, the double negative makes this 8 plus 3. And on the bottom, 2 minus 2 is 0. 8 plus 3, of course, is 11. Now, what's interesting about division or fractions is that when you divide by 0, or 0 is in the bottom denominator, you end up with an undefined value. Okay, so this actually is not a value at all, it's undefined. And so m, we would say m is undefined. Okay, and you can imagine this maybe being if I had $11 and I wanted to divide them up between 0 friends, how much would each friend get? Well, there's no friends to get anything, so there's really an unanswerable question. Okay, so in some sense that's undefined for that reason. There's other reasons mathematically that's undefined, it's just kind of the way I think about it. So m is undefined, and so anytime you have an undefined slope, oh, I should show you the graph before I get into the summary. The graph of this, if I look at the point 2 comma negative 3 over 2 down 3, and if I look at the point 2, 8 over 2 up 8, they're going to line up on a vertical line. Okay, so they line up on a vertical line, and so anytime you have an undefined slope, the line will be vertical, and that's because, and that works for every vertical line, because whenever you have a vertical line, the 2 points will always have, or every point actually, will have the same x value, and the x values being the same, when you put them in on the bottom, they subtract off and get 0, right? Anything minus itself will be 0. All right, so when so if you have an undefined slope, you get a vertical line. Okay, and so that gives us our 4 different directions of a line based upon the 4 different values for a slope. We have positive slopes going up to the right, negative slopes going down to the right, 0 slopes are horizontal, and undefined slopes are vertical. And that should give you your 4 different types. Okay. Now there's one other thing in this section that I think is going to be very, very important. And that's another formula that we can derive from this one. Okay. So let's take all this stuff away for a moment. And let's go back to our slope formula, or the idea of a slope formula. I'm going to take 2 points. I'm going to graph them real quick. Let's say you had a line. It doesn't have to be going up to the right. It could be any line, except an undefined line or undefined slope. I don't want to deal with those. Okay, but anyway, let's say you had a line, and let's say the y-intercept. Y-intercepts are always represented by having a 0 in the x-coordinate, right? Because any point on the y-axis is going to have a 0 in the x-coordinate, right? It's 0 horizontally. So I'm going to call that 0 comma b. Now the b is just whatever the height is. It's the y value, okay? The y value of the y-intercept. Now the other point I'm going to choose, I'm just going to choose a general variable point. It could be any point on the line. So I'm just going to call it x and y. Now I'm going to take these 2 points and plug them in to my slope formula. Okay, so m is equal to y2 minus y1. I'm going to go with the y as my y2 and the b as my y1. So I'm subtracting the y values. Y minus b over Now I get the x2 minus x1, so that's going to be x minus 0. Okay? Now if I simplify this, x minus 0 is just x, right? Anything minus 0 is itself. So I get y minus b over x. Okay? Now, when you have a fraction in an equation, we learned back in chapter 1 that you can eliminate that fraction by multiplying both sides of the equation by the LCD. Well, in this case, the LCD is just x. And so I'm going to do that to get rid of this fraction. Multiply by x and multiply by x. Now, on the left side, I get x times m, or I'm going to write it alphabetically, so it's mx. The order doesn't matter when you're multiplying. On the right side, though, the x's cancel, and I'm left with just y minus b. Okay? And now, what I'd like to do is actually solve for y, because that's kind of the easiest variable to solve for in this equation. To do that, I'm going to add a b to both sides. So if I were to add b, add a b, well, the b's will cancel out on the right because they add up to 0. But on the left now I have mx plus b. They're unlike terms because the variables are different, so I have to keep them separated. So we get mx plus b. And on the right side, all I have left with is the y. Okay. Now, equations have this property where you can switch the sides and it doesn't really matter. It doesn't change anything. And so, when you solve for a variable, we typically like to list that on the left. And so I'm going to write this as y equals mx plus b. Okay? So y equals mx plus b. Now what this gives me is an equation that I could actually put in function notation. Remember earlier in chapter 2, we can write an equation like this in function notation, like f of x, where in this case, the m and the b are very specific values or very specific parts of the graph. The m obviously is the slope. The b is going to be the y-intercept, okay? And so the m is the slope. The b is the y-intercept. We use the letter b because we often use the letter a for the x-intercept, right? So x or a and b are the x and y-intercepts respectively. So the slope and the y-intercept are in this equation, and the slope will always be the number multiplying the x, and the y-intercept will always be the constant in a linear equation. The form of this is called the slope-intercept form. Okay, slope-intercept form. So this is the slope-intercept form of a line. So if we look at a quick example, just any function in that form. So anytime I have a function that looks like f of x or y, it doesn't matter. F of x equals, 2x minus 5. Well, that tells me right away that the slope is 2 and the y-intercept is negative 5 because the 2 is multiplying the x, the negative 5 is a constant. So m is 2, b is negative 5, and so on a graph, I know immediately that my line goes through the point 0, negative 5. Okay, 0, negative 5. And it has a slope of 2. Well, having a slope of 2 gives you a rise a rise of 2 and a run of 1, right? So for every 2 you go up, you go 1 over, okay? And so here I would go, in order to graph the rest of this line, from that 0, -5, I might go up 2 units over 1, and that would give me another point, right? So if I go up 2, right 1, that gets me a second point on the line. It's going to be at 1, -3. Okay, that's going to be the next point on the line. And I can continue that process going up 2 over 1, up 2 over 1, and I will get a nice increasing graph or increasing line to the right, okay?